Determine the values of x and y at which the stationary point of the following function occurs. Find the nature of the stationary point. Alright, so we looked at previous videos concerning stationary points, and we saw that to locate the stationary point, you find delta f by delta x equals 0, delta f by delta y equals 0, and solve to find x and y. Then after that you find the second partial derivative, delta squared f by delta x squared and delta squared f by delta y squared. Now if both are positive and positive, you have a minimum point. If one is negative and the other one is also negative, you have a maximum point. If one is positive and the other is negative, or one is negative and the other positive, you have a saddle point. Alright, so given that reminder, I want you to pause the video and work this out. Okay, good. You finished? Let us see how this goes. Now, delta f by delta x in this case would be 5y minus 2 times 6 is 12, 12x plus 7, okay, equals 0 at the stationary point. And then delta f by delta y is equal to, what would it be in this case? 5x minus 2y minus 2. And that is equal 0 at the stationary point. The next thing to do is solve them simultaneously. Alright? Now, it's going to be a pair of simultaneous equation. Could say, so you put the x parts first. So you have negative 12x plus 5y equals negative 7. Let's put the number on the other side. Subtract 7 equals negative 7. Let's call this equation 1. Alright? That's equation 1 there. And then 5x minus 2y equals 2. And we call that equation 2. Alright, so how can we solve this? Well, should we use elimination, substitution, or what? Let's use elimination. We eliminate. By the way, it's kind of awkward working with so many negative values. Let's multiply both sides of equation 1 by negative 1. So we have a positive 12, positive 7, and a negative 5. Alright. So let's work with that. Less confusing and less stressful on the brain. Now, let's say equation 1 by 5. So we have 5, 12, 60. X minus 5, 5, 25. Y equal 5, 7, 35. Let's call this equation 3. And then equation 2 by 12. We have 12, 5, 60. X minus 12, 2 is 24. Y equal 12, 2 is 24. Let's call this equation 4. Now, equation 3 minus equation 4 will give us 60x minus 60x, that's 0x. X is gone. Then we have negative 25 minus negative 24. That's negative 25 plus 24. And that will be negative 1. So it's negative 1y equal. And then we have 35 minus 24. So 35 minus 24 gives us, what do you get? 11. So negative y is equal to positive 11. So that means positive y is equal to negative 11. Alright? So now substitute y is equal to negative 11 in equation 1. Alright? So 12x minus 5 times negative 11 equals 7. So we have 12x plus 5, 11, 55 equals 7. So 12x is equal to 7 minus 55. You have 7 minus 55, that will give you what? Negative 48. So x is equal to negative 48 over 12, which is negative 4. Alright, so you have negative 4. So that means stationary point is located at x equal negative 4, y equal negative 11 along the z-axis. Z would be what we call f, the function of x and y. So what would it be? Well, we were asked for the values of x and y. But out of curiosity, let's find z. That would be x is negative 4, y is negative 11. So if x is negative 4 and y is negative 11, we have 5 times negative 4 times negative 11 minus 6 times negative 4 squared minus negative 11 squared plus 7 times negative 4 minus 2 times negative 11. So let's use a calculator. Negative 4 by negative 11, that will come out as a positive. So 5 times 4 times 11 will give us 220 minus 4, 16. 16 times 6 gives us 96 minus 121 minus hold on, what is this? Plus 7 times negative 4. Alright, so 121, then 7 times negative 4 is minus 7 4 is 28, then minus 2 times negative 11, so it would be a plus 22. So we have 220 minus 96 minus 121 minus 28 plus 22 was negative 3. So z would be negative 3. I didn't need to do that because I didn't ask for the z, just the x and y. But just wanted to see where that z would be located. Alright, they asked us for the nature of the stationary points. Alright, so we have the first derivatives. Let me just copy the first derivatives instead of writing them all over again. Alright, so let me just drag that down. Alright, so we have the first derivative there. We need to find the second derivative now. Delta squared f by delta x squared would be this with respect to x is negative 12, and delta square f by delta y squared would be delta y squared, that's negative 2. Alright, now both of them are negative, which means both of them, when you move, they would be swinging down, so it's a maximum point, right? Well, at least that implies a maximum point. But let's test it further. We saw earlier that if we have delta squared z, well, in this case f delta squared f by delta x squared multiplied by delta squared f by delta y squared, if that minus delta squared z or delta squared f by delta x delta y all squared. Now, if that is a positive, then what you will have in that case is a stationary point. I mean, it's a maximum or minimum point. So positive, max, or min. In this case it will be maximum. But suppose it's a negative. What would happen? And that would be a saddle point. Well, let's see what happens here. If we want to test this, we also have to find delta squared f by delta x delta y. Now, delta squared f by delta x delta y, we have delta x here, right? Delta x delta y is the same as delta y delta x. So let's find delta x and then delta y. We found delta x here, so let's find delta y now, equal 5. And if you notice, we found y here. If we found delta x, we get 5 as well. So let's see what will happen. We have negative 12, which is delta squared f by delta x squared, multiplied by delta squared f by delta y squared. In that case, negative 2 minus, and then 5. We see what happens here. Negative 12 by negative 2 is positive 24 minus 5. When you say negative 12 by negative 2, positive 24 minus 5, you get 19. Alright, so it's not a saddle point, it is indeed a maximum point. Alright? So you have a maximum point there.